horrify us.
You are the man who gave them the power to destroy themselves.
Fortunately, I have quantum mechanics to help me out. This is not science fiction.
Hey folks, welcome back to another video where we'll explore how Sean Carroll relates quantum mechanics to our everyday life. So stay tuned until the end. A famous physicist, Feynman, said, "I think I can safely say that nobody understands quantum mechanics."
Quotes from people like Richard Feynman saying nobody understands quantum mechanics, right? And
But what if I say that Sean Carroll predicts that we might have quantum money in the future that you will be using for buying your favorite brand's t-shirt or order a pizza? Sounds impossible, right? I can understand, because that's what we believed a few years back when we saw the movie I, Robot and thought, this can never happen. However, we all know that artificial intelligence has already taken over the world. Even if we believe what Sean Carroll claims about the relation of quantum mechanics with our everyday lives, we still need a detailed explanation, right? Several years after Newton, a man claimed that classical mechanics had many errors. Then he must have something great and worth it to say. To simplify things, let's divide Sean Carroll's explanation into chapters to digest it quickly. Chapter 1. Physicists don't want to know about quantum mechanics anymore. You are using quantum mechanics every day in your life. For example, most of the predictions are based on quantum mechanics, and results derived from experiments are all based on the rules of quantum mechanics. You already know how to operate an iPhone, and you're sending and receiving signals, but if you're asked what's actually inside it, you'll have no idea what's going on because you don't care what's inside that iPhone. Yet sadly, that's the relationship physicists have with quantum mechanics. If you ask them about the deep down science of quantum mechanics, they will not have an answer for you because they believe it's not workable in our lives anymore.
And that's physicists with quantum mechanics. They use it. They can make very, very precise predictions, but if you ask them what is really going on, like what is actually happening, what are all the details, they're like, yeah, no, that's not our job. Let's just stick to predictions.
But the truth is completely opposite. Well, if it's only between you and your iPhone, it's fine.
Physicists, of course, do quantum mechanics every day, whether it's, straightforward quantum mechanics, quantum field theory, quantum information, quantum computing. Clearly, we're pretty good at it, like transistors and lasers depend on quantum mechanics. The sun shining, figuring that out, depends on quantum mechanics, the Higgs boson, etc. So to claim that we don't understand quantum mechanics...
The most embarrassing thing a physicist can do is refuse to answer questions about quantum mechanics. If a physicist doesn't know about quantum mechanics, that's no big deal. But only if he has the urge to learn more about quantum mechanics, because it will lead to exploring the unanswered questions. What's actually worse? When the physicists think like a layman, considering that we do not need to know about it anymore because it is not related to our lives. It was only back in the 1920s when physicists joined their heads and settled around the table to find out what was going on inside our universe. However, now things are not like that anymore. We are using quantum mechanics and sending rockets and spacecraft to other planets, but no physicist is bothering to dig deep down under the applications of quantum mechanics. And it's just like a fox who asserted that the grapes are sour. That's why Sean Carroll has taken a step ahead to explain that quantum mechanics does have a role in our lives, and physicists need to understand it with a bigger exposure, especially when Sean Carroll asserts the laws of classical mechanics to be a failure. Chapter 2. It's not mystery, it's not magic, it's just science.
It's great, but
Thank you.
I really appreciate someone like you who's trying to break down quantum mechanics and quantum physics for someone like me.
Think of a beautiful summer day in 1687. An apple falls on a man sitting under an apple tree. The moment when the apple hits his head, he gets an idea and stands up excited to explore something that no one has thought about. This led to the formulation of the universe-changing gravitational law, which I assume you already know. But later on, he ponders upon the motion of the objects with their relation to the external forces and comes up with the laws of classical physics. Until now, every scientist and physicist had believed those laws and even related them with the creation of the universe, the movements of the stars, the earth, and every other object. Even the tiniest bit of any object in our universe, an atom, follows the laws of classical mechanics. Simply following Rutherford's picture of an atom, physicists kept a belief that an atom has a dense mass in the center, while the electrons keep on moving around it in smooth orbits until an external force hits them. But Newton and Rutherford never expected that soon their concepts and theories would be challenged in the 20th century by a never-ending war between classical mechanics and the entry of quantum mechanics. Chapter 3, Newton was wrong. Yes, you heard it right. That's what Sean Carroll has already said, and that's where the twist of this explanation starts. Quantum mechanics is a replacement for all the laws of classical mechanics where we can assume that Newton was wrong. You have always been told the picture of an atom considering the Rutherford's model. The atom's nucleus sits in the center while the electrons revolve in orbits, and they can jump from atom to atom, being successfully used in electricity and other projects. But what if I say that this whole thing is actually nonsense? Considering the electromagnetism theory of Michael Faraday, a charged electron has an electromagnetic field coming out of it, especially when an electron is shifted to another level. It emits electromagnetic radiation. As a result, the electron emits energy and an atom collapses in 1/100th of a second. However, this does not happen, which means classical mechanics no longer holds any relevance. If classical mechanics is a failure, then now is the time to dive deeper and understand what quantum mechanics is and what is its role in our everyday life. Chapter 4, How we use quantum mechanics in everyday life. Carroll asserts that using quantum mechanics in everyday life doesn't necessarily mean you will get a faster train to reach your destination faster or get a better iPhone that takes better pictures.
They were so afraid to really take it seriously and try to understand it. Like they said, stop asking questions about the meaning of reality and what the world is doing. In my mind, what physics is all about is understanding reality and what the world is doing. It's not just about making predictions. Making predictions is good, but we do that, mostly because we're curious about what the world is doing.
The purpose is to understand the fundamental reality of the existence of our universe. In terms of quantum mechanics technological applications, we already have them in our everyday lives, such as the toaster in your kitchen that uses quantum mechanics to heat up and prepare tasty food. In reality, we are trying to figure out whether multiple worlds exist. We're also interested in knowing about what happened during the Big Bang because all the laws of classical mechanics are no more than fluff. However, we cannot deny the fact that understanding the bigger picture of this universe will help to bring more advances in technology, even if they are yet unanticipated. Chapter 5, Quantum Computers with Huge Data Storage. The idea of making a quantum computer, which was first presented by Feynman, is only possible when you explore quantum mechanics. You might not have a quantum iPhone, but what if these quantum computers could make complex physical systems and even break codes? Chapter 6, Classical versus Quantum Computers. Today's computers operate on bits, which are systems that work with 1 and 0 values.
In quantum mechanics, you have a quantum bit.
A qubit, as they call it. Very clever.
So in quantum computers, if you manage to have a qubit, which you may call a clever name for a quantum bit instead of having a bit, it is hard to say how much data can be stored. Scrolling back to Newtonian classical mechanics, we have a solar system with a sun and the planets revolving around it. Each planet has its own velocity and way of motion. But what if you could understand that using quantum mechanics? Instead of tiny bits, we will have huge waves because quantum mechanics works in entangled waves, and you cannot separate them. This means we are talking about a huge system. In the long run, this will allow new ways and methods for computing and analyzing data on a larger scale. It may be easier to talk about the entire system instead of each bit. So this means that a quantum computer can store enormous amounts of data compared to a classical computer. And what if you manage to decode that information? Of course, with the massive amount of this stored data, we can open up many possibilities in our universe for us and the people coming up after us. Chapter 7: Encoding Quantum Money with Quantum Cryptography.
So things like cryptography, privacy, right, are dramatically changed by this, because one of the things that we think quantum computers should be able to do faster is factor large numbers, which is the difficulty in factoring large numbers is the basis for much modern cryptography.
Another possibility to use quantum mechanics in the future is to keep more things secret, like you may have quantum cryptography. This will involve breaking other people's codes and inventing your own specific and unique codes that no one can interfere with. You can think of having quantum money that would be even safer to make transactions because it will all work like a blockchain. Ending this video, we can say that Sean Carroll has twisted the mechanics that we believed and understood until today, because he accused all the classical mechanics by Newton. The way he looks at quantum mechanics and how it may be applied to our future is opening up new horizons of opportunities and possibilities for physicists.